So the last thing we have to name are acids. So an acid is a molecular compound that reacts with water to produce an H+. So you have all acids are going to have a hydrogen in front of it. And that's what we're going to look for. So an ionization reaction, what's happening here is you have something like hydrochloric acid, so this is HCl. When you put HCl in water, it's going to dissociate into ions. It's going to ionize into H+ and Cl-. That's what happens when you put an acid in water. And so this is an acid. Acids are going to have an H in them, and then they're going to have another piece to it. And really, it's this other piece to it, in this case, the chloride ion, that's going to determine what the name of the acid is. You can have monoprotic, diprotic, or triprotic acids, depending on how many hydrogens you have that can come off. So monoprotic has one ionizable hydrogen. Diprotic acids have two, triprotic are three, and polyprotic is just a general term for diprotic and triprotic acids, anything that has two or more ionizable hydrogens. You may see that word again, polyprotic acids. When we name acids, we're really looking for two types. We have oxyacids, where it's basically hydrogen and then oxygen and something else, so something like HClO would be an oxyacid. It has a hydrogen, an oxygen, and then something else. A binary acid is just going to be something like HCl, so hydrochloric acid, where you have hydrogen and chlorine. So oxyacids have an oxygen in them. A binary acid will not have oxygen in it. All right, so how do we name these things? So for oxyacids, all we're really doing is we're looking at the polyatomic ion that is with the hydrogen. So you're going to have hydrogen and then a polyatomic ion. Hydrogen, polyatomic, hydrogen, polyatomic. And what we have to do is just name the polyatomic ion, and if the name of the polyatomic ion ends in 8, you're going to drop the 8 of that name and change it to ic acid. So for example, this is chlorate, right? So just cover up this hydrogen for a second, and ClO3- is chlorate, right? So that's chlorate. So what you're going to do is you're going to drop the 8 and add ic acid, and this just becomes chloric acid. The hydrogen is basically telling you it's an acid. So this NO3 is nitrate, right? Nitrate. So drop the 8 and change it to ic acid. So this becomes nitric acid. This is bromate. It looks a lot like chlorate, but instead it has a bromine in it. We didn't really have this on our list before, but bromine, chlorine, and iodine, they all form similar kinds of compounds. So if you know that this is chlorate, right, then this is bromate, and this is iodate. There's like a whole series. And it only works for those three, fluorine, bromine, and iodine. They're all halogens. You remember where they are in the periodic table? Let's go back to our periodic table. Chlorine, bromine, and iodine are all in the same family. They form similar types of compounds. So if we remember chlorate, then bromate looks like chlorate, BrO3-, and iodate is IO3-. So just by knowing that one and the trend, we were able to get the other ones. So this is bromate. So what do? I drop the 8 and I change it to ic acid. So this is just bromic acid. I don't know why there's a delay on my pen here. Let's see. So if it ends in ite, you change the ending to us acid. So again, it's going to be hydrogen with some polyatomic ion. All right. So here's another series of things that we polyatomic ions, so we can get more names. So this is chlorate, right? ClO3-. And it turns out that chlorite, so just change the ending to ite, you get rid of one oxygen. That's ClO2-. And then you can also get rid of another one, which is ClO-, and that's called hypochlorite. And if you wanted to add one more oxygen, we'd have to add a prefix to it. So now that's perchlorate. All right, so we started off with chlorate. We got rid of one oxygen. We got chlorite. If we get rid of another oxygen, remember to go from 8 to ite, you just drop an oxygen. The 8 an extra oxygen. Think about that. to go from chlorite to hypochlorite, you just get rid of another oxygen, and then if you want to add one, you add another prefix per. So these are prefixes: hypochlorite, chlorite, chlorate, perchlorate. The 8s are going to have more oxygens than the ites. This also works for the bromine series. So you have bromate, you can get to bromite, hypobromite, perbromate, iodate, iodite, hypoiodite, periodate. So ClO2 minus is over here. This is chlorite, so I'm going to drop the ite, and now I change it to us acid. So this becomes chlorous acid. Chlorous acid. This is nitrite, so I drop the ite, and it just becomes nitrous acid. Nitrous acid. This is bromite. So this is chlorite, so bromite does the same thing. So bromous acid. So all we're doing is trying to change the ending of the you look at the polyatomic ion, change the ending to, if it's 8, change it to ic acid. If it's ite, change it to us acid. Now for binary acids are a little bit different. You look over here, this ends in chloride. This is chloride because it's the chloride ion. If it ends in ide, you're changing the ending to ic acid, but you also have to add a prefix, and that prefix is hydro. So this is hydrochloric acid. So I took the chloride, right? This was chloride. I dropped the ide, changed it to ic acid, and then I added a prefix hydro. So only the binary acids are going to have the hydro in it. So the ones that don't have oxygen are going to have hydro. So this guy came from bromide, the bromide ion. So I have, instead of bromide, I'm going to drop the ending of ide to ic. So this is bromic acid. And I need to add this prefix, hydro, to start off with hydrobromic acid. Same thing with iodine. This is going to be hydroiodic acid. Hydroiodic acid.